the TPS committee is really working in several areas, but our focus is to develop software and specifications that are aiming at the regular operating system. So whether that be Linux or whether that be some kind of RTOS. And we have a number of projects going on, but there are particularly some projects that are intended to have open source implementations. And these are around providing security services to the regular operating system and to application developers. Standard security services that would be hosted in a secure component, so something like a TE or a secure element, and in fact even through cooperation that we have with the Trusted Computing Group with a TPM, for example. So really the idea is the application developer can take the code that we're going to provide and they will be able to develop a system that is completely agnostic on which type of security component they use to provide their security services. So right now we have a TPS client API, which is the sort of entry point to all of these services, provides service discovery and a common API set. And then we're looking at initially at a key store and at entity attestation so that you can make some securely backed assertions about the device, whether, for example, it is running secure boot, what firmware versions it's running, whether debug is enabled, those kinds of things which can be useful to relying parties who want to understand the environment that an application is running on. So I mentioned that we have a very close cooperation with the Mobile Platform Working Group at TCG. We have pretty much monthly meetings with them, and that's been going very well. They've been running for a while. And like I say, the first intention here is that their technology will be just seamlessly a part of what we're doing. But on top of that, we have tried to build on some foundational technologies that are being developed elsewhere, mainly at the IETF. Again, for maximum interoperability and really for being understood by developers. So we're using CBOR as a sort of foundation for our technologies. And in attestation, we have a specification called the Entity Attestation. And there is an IETF draft that's going on there, and we contribute to that. I'm one of the authors, in fact, on that draft, although by far not the main contributor. We've also made contributions in the area of CDDL, which is something needed. So, you know, very much we view the best other work of standards bodies as something to build on, and then to add the unique security focus that global platforms may be particularly well known for. The Entity Attestation Token is a very, very generic, broad specification that is designed to allow you to make claims that can be verified about all kinds of things. This could be something as large as a refrigerator or a car, or it could be something as small as a tiny sensor. Now, within GlobalPlatform, we have some very good, well-proven and very widely deployed security technologies. So we're particularly interested in using the capabilities that the Entity Attestation Token offers to provide those kind of assertions about claims that are really backed by being generated in and signed by a security component. So, for example, you can trust that your regular operating system booted correctly because the TEE actually monitored and measured that secure boot. Similarly, you can trust that your keys are stored correctly because they are in a security component that's really designed to do just that. There are really several things that open source can bring. The most important is really ease of use. So a challenge for a developer, if they are looking to sort of deploy in their product a specification that's maybe 200-300 pages long, is just the sheer amount of effort that goes into that. And in reality, that's an effort that is mostly going to be undertaken by each company that wishes to use the technology. So you could imagine with a really successful technology, you're going to see, many tens of essentially identical implementations. So the first thing that open source is really giving is the opportunity to, share the development of the part that is really wants to be interoperable and is not really unique to or special to a particular product. The second part is it is much easier to actually use these types of services if there's code there, if you've got nothing to do, and if you've got reference designs and even reference platforms that allow you to see how this stuff works, how it hangs together, and even if you have to change things a little for your own platform, you're able to look at how somebody did it on a similar platform before and take from that. And the third thing is, increasingly, as standards become complex, it is often really difficult to verify that the standards are actually correct and ensure that they're reasonably consistent. So by having an open source implementation, we'll have we'll be able to make sure that the specification itself matches something that works. And so hopefully ambiguities and the like are not there. It's probably also important to say that in some of these foundational technologies, in CBOR, COSE in particular, and CDDL to some extent, there's not maybe as much tooling out there in the market as ideal. And so for GlobalPlatform to offer high quality implementations that are suitable for embedded use and being written in Rust, which is the programming language we've chosen, hopefully not vulnerable to a lot of the type of memory safety leaks that we sometimes see. This is something that people could incorporate in their products with good confidence. And we've chosen our licensing, everything is MIT licensed, precisely because it's a really compatible license. It can be used in just about any product. So we're at a fairly early stage. The first open source code has only been committed to GitHub in the last couple of weeks. Some of that code has been under development for a longer time, but currently we have a moderately complete CBOR implementation in Rust, and then we just have a small part of CDDL. Gradually over the next few months, we will start to see a few more of the components that are under development coming in. And we have a number of commitments from member companies who have said, we plan to use this technology within our, some of our future open source offerings. And whilst I'm not in a position to be public about that, I hope that that people will be looking out for announcements in the future from GlobalPlatform members along exactly those lines. So it's an early stage for people to contribute. Contribution has been made quite easy. So the project is hosted on GitHub, which is very well known to most developers. We've chosen an MIT license, which, like I say, is a very compatible one, and one that most companies have not too much difficulty to work with. We've tried to choose a fairly simple set of open rules that in principle allow anybody to contribute, but at the same time just provide some safeguards to ensure that contributors don't suffer from, for example, their accounts being hijacked or the like. So the rules are deliberately simple and straightforward. The licensing is deliberately simple and straightforward, and we hope that that will encourage people. I'd particularly say that to experienced embedded developers out there who've maybe been working in C or in C++ for a number of years, this is a really good project if you feel like learning Rust on something that's real world, and if your employers or your free time will allow you to do it. This is a fantastic project for just that kind of thing. Truth be told, it's probably why I started the work in Rust myself, and I've really enjoyed the experience. It's a great programming language. Establishing trust starts really all the way back down at the silicon. because ultimately you have to trust the silicon that you're running on. Beyond that, you have to trust some of the components that you're using. So, you know, if you're running on top of a TE, you're trusting the silicon, you're trusting the firmware that booted that TE, you're trusting the TE vendor. That's an absolute minimum, and usually there are many more parties that you need to trust. So end entity attestation is very helpful in establishing for you, yes, actually, what is it that I'm running on? What is this? Are we running in a virtual machine, or is it actually running on real hardware? And some of these things are already in place. You know, we see a lot of initiatives in IoT, and there's way more work to be done. For the United States, there's a recent executive order on software, sort of, I'll say, bill of materials, and really what things went into making the component you have, and that's something we'll probably be looking at in the near future. In the end, all that we can do is provide better tools that allow the end user to understand what it is that they're running on. And, you know, at the next stage, then you start to think of certification and programs like GlobalPlatform's security certifications that really start to give you an independent third-party view of, you know, is this thing that I'm using, is it fit for purpose? Was it well designed? So there are a lot of things that have to come together for trust in IoT. In my view, large bodies of good quality code put together by security experts and making use of the best security technologies we have, like the TE, the secure element, and TPMs. These things all help, but they're only a partial solution, and yeah, there's a long way to go.